All right, so the cumulative assignment number 4 talks about the sinusoidal function, where, similar to the exponential, this would be 2 sine 3x. I don't know if it's minus pi, or depending on how we do it, plus pi minus 3. Well, yeah, we'll code that. So I'll need to remember that I did a positive c there. Okay, so but that's this function, and it gave you a little bit of information about a sinusoidal. It's the wave functions. Sine of x, and any cosine function can be written as a sine function, which is why we call them sinusoidals or sinusoidals. Okay. All right. So to implement this class, it's going to be really close to exponential, right? It's got to be, let's see, sinusoidal. We do want it to extend function. And I'm just going to keep consistent with what the C1, D1, the way it did it in the reading. It called it A, B, C, and D. Okay. All right. So now we got to change get y, because it's not an exponential function. We're not doing power, right? We're doing sine function. Okay, so let me think. This will be y equals a sine bx plus c plus d. All right, and again, just get y. You put in an x value. A, B, C, and D are all coefficients. Right? It defines like the period of the graph, the phase shift, the vertical shift, the amplitude. Those are coefficients that define what the wave looks like. But if you put in an x, you get out a certain y value. So this would be a times sine, and I need to make sure this is in radians. I'll have to check that, but this is b times x plus c, and then plus d. So that is get y. Yeah, that looks right. Now on the graph program, if you graph a sinusoidal and look at this, keep this window. Let's just see it first. Yeah, it actually looks pretty good. So, if you wanted to graph one period of this function, it looks like the period would be 2 pi thirds, right? 2 pi divided by b, 2 pi thirds. So like I could do, I'll try to change this back, but x to 2 times pi divided by 3. Let's just see that. Now it's going to be squished, but that's one wave. And if I wanted to do what we call a tight graph, I could go from -5 to -3. No, -5 to -1. I think that's right. So if you have a vertical shift of 3, your midline of your sinusoid is going to be at -3, and then the amplitude says, okay, go 2 above that, that's -1. Go 2 below that, that's -5. So you're going to see this like tight graph here. Now, and you can even see this is interesting because the way our graph program works, our draw function, it basically is drawing points whenever x is 1/100th away from each other. It goes up every 1/100th. Well, if you zoom in close enough, and you could do this on a calculator too, if you zoom in close enough, you'll see that those values are just points, right? They're just drawing points. The thing we first started out with, and there, you can see some gap in it. But that's a tight graph, right? It's the minimum hits y min, maximum hits y max, and it's one period here. So I'm going to change this back before I forget. negative 10, semicolon, x max, okay, is 10, negative 10, y max, 10. Try that again. This is the original. Yep. Okay, so that is the sinusoidal class.